Hello, and welcome back to the Rawkode Academy. Today is an episode of Rawkode Live where we are taking a look at a new open source tool from the team at Robusta to help you improve your Kubernetes resource optimization. To guide us through our demo today, I am joined by Nitin. Hello, how are you?
Good, it's a pleasure to be here.
Yeah. What is this? Stream number 3 together, I think. So, 5 months ago, we looked at what was it? Kubernetes monitoring. And a year ago, we took a look at Robusta. So pleasure to have you back.
Pleasure is mine. Yeah, a lot has happened since then, both in terms of Robusta and also my personal life. I just have a newborn baby at home now, so it just feels like it's been so much longer.
Well, congratulations. It's a wonderful thing. A hard thing, but a wonderful thing.
Yes, thank you.
For anyone who hasn't seen any of our previous episodes, isn't familiar with you and your work, which, shame on them. You're doing some great stuff right now in the Kubernetes space, and people should definitely be checking out your blog and stuff. But do you want to give people the TLDR and share whatever you'd like to share?
Yeah, so what we do at Robusta, rather, I'll start with the problem. The problem is that there's two problems. The first problem is that people have all this observability data. Sometimes terabytes of observability data that's sitting there. But when there's an incident and when something's going on in production, then finding the right thing to look at, fast is often very difficult. So what we do at Robusta is to try and help you take your observability data, your existing observability data in Prometheus and other places, and to extract from that meaningful and actionable insights. And there's several ways that that comes about. So we have an open source project that takes your Prometheus alerts and then adds on extra data and ties it to logs and so on. Then there's KRR, which we're going to look at today, which is about taking your existing Prometheus data and using that to now extract insights about efficiency and about CPU request to memory. And then, of course, we have a commercial platform as well.
Awesome. Well, I think we have Pavan and Elbe at the chat. Elbe says congrats, and Pavan says hello, who I believe is on the Robusta team, right? Awesome. So today, as you said, we're taking a look at KRR, a tool for Kubernetes resource optimization, trying to help people with scaling workloads within their cluster. But maybe before we dive into the demo and talk about what KRR does, we can kind of understand what the challenges are right now with workloads in Kubernetes and, resource requests and vertical pod auto scaling. There's a whole bunch of stuff that isn't really there by default, right? It's not like you just create your deployment, you get your pods and things magically work. I mean, they could, but as your cluster grows and more workloads come on, and the older your cluster is and the more teams you onboard, there's a plethora of challenges that are inevitably going to come your way. So, what's your experience of working with Kubernetes, onboarding new workloads, and where do things start to creak and fall apart?
So there are a few stories here. The first story is that we had this, you'd expect that as we move to the cloud, right? And we adopt all this great technology and we adapt Kubernetes and we adapt all these things. Then you'd actually see that we're, as like an industry, we're becoming more efficient and we're becoming more reliable. But in fact, if you look at the past year, then we've almost seen the opposite happen with incident after incident after incident. Just last week, Instagram, just this week, I think Instagram was down for a couple of hours. And what you see is that we're not we'd expect that we're adopting all this great technology. You're going to Kubernetes, and you're getting all these great things, and then your system is becoming better. But instead, there's all this added complexity. And I think a lot of that complexity is justified. It's good. You're getting these benefits. You're getting auto scaling. You're getting all this stuff. But to set it up and to configure it can sometimes be a little bit challenging. And then if you double click on that and you zoom really in, specifically on Kubernetes and scaling, then there are two things that you're always trying to balance. So on the one hand, you want to have something that's really efficient. So you don't want to allocate all these resources that you don't need. On the other hand, though, you want to guarantee reliability. And those always come hand in hand. And there's a trade-off between them. And what I mean by that is, let's say you have one application that requires 10 CPU, that requires one CPU, and occasionally it requires 2 CPU, right? Then if you give it 2 CPU, then you're going to satisfy the reliability, right? And maybe sometimes it can spike to 3 CPU. So give it 10 CPU, give it 100 CPU, right? You're never going to have a reliability issue, but you're going to have a cost and efficiency issue. on the other hand, if you take that same workload that requires one CPU most of the time, you just give it one CPU, now you're going to run into reliability issues when it needs two. And all of the different technologies involved in like an HPA and the VPA and scaling and cluster auto scaling, all that is about trying to balance those constraints, and you balance it each time in different ways, but there are always trade-offs. And I think that's important to understand. Like you will never have 100% efficiency and 100% reliability, because by definition, there's a conflict between the two of those. Because with reliability, you're looking at the 1% edge case, and with efficiency, you're looking at the 99% case.
Yeah, I mean, I guess to try and summarize that in like a single line, right? To understand that trade-off is that you could get really good resiliency and redundancy and all of that stuff on the happy path, but it's the expensive path. Like you over provision 300, 400, 600%, whatever you want. If you've got the money and you want to throw it away or set it on fire, sure, go for it. Like, yeah, you're going to have a better time. Maybe not an easy time, but a better time than most. However, most organizations can't just over provision to that kind of level. They want to reduce costs when they migrate to the cloud. In fact, cost is usually a portion of why they're doing this. You know, they're making the swap for operational expenditure versus capital expenditure, or whatever that term is. I'm not a business person. So then what they want to do is, well, they set all these resource requests so that they say, okay, I expect these workloads to do this. We have a buffer of 20%, 30%, whatever that is for your team. And then you try to scale within that and scale your cluster and your pods at the same time. But that's the tricky path. That's the hard path, because it's your workloads constantly move, they constantly change, nodes are ephemeral, they're not always going to be there. All of these things really start to compound and provide a pretty strong challenge for your platform or SRE team to keep the cluster healthy, the workloads healthy, and your customers happy.
Yes. It's like you can choose 2 out of 3, right? It's always choose 2 out of 3. So you have reliability, efficiency, and simplicity. And I say you can choose 2 out of 3 because you can get close with efficiency and with reliability, and like kind of trying to have both of them, but then you go up in terms of complexity. Like if you think of your cluster as a pizza party, then and you're throwing a party and you don't know how many people are going to show up. So either you order more pizzas and you end up throwing some of them away. So that's the trade-off with efficiency. Or you order like the lower bound of pizzas and then people come, they're hungry. So that's reliability. Or you do something complex where you're counting how many people come in the door and you're looking at the pizzas, and then you have a delivery guy coming back and forth every hour. And that's the trade-off with the simplicity. But let's take that now into Kubernetes, and let's zoom in on Kubernetes. So I want to take an example. Actually, I want to take some statistics from a recent Sysdig study, and they looked at all the people running Kubernetes in production that they had access to based on data sent to Sysdig. They looked at all these giant environments and lots of clusters, and they categorized it by like big business and small business and enterprise. And they looked at all these companies, and what they found is that 69% of all the CPU that people are paying for is actually wasted. And that's an incredible number. And then to translate this, though, people don't see that because you open up Lens or you look at your cluster and you don't see, you're not seeing anywhere 60%, 69% waste. What you see instead is you go and you look at a node and you see your node is full and there's no room on your node. Maybe you have pending pods, but then you look into the node and you see the CPU is at 10% and you have low utilization. So to understand all that, I think you need to start at the basics, which is setting just 2 numbers on Kubernetes. Everything comes down to ultimately setting 2 numbers, arguably 4 numbers, but we'll start with the 2 basics, right? And that's your CPU request and your memory request. And the way to think about this for people who aren't familiar is you're telling Kubernetes in advance how much CPU will you need for this pod and how much memory will you need for this pod. And that's just the request. It's just used by the scheduler to decide which node it should put your pod on.
Nice.
So the reason why we're here today and what we're doing with KRR is we're just trying to help you set those 2 numbers.
Well, it's a noble mission. I'm curious though, right? Where were you sitting? What were you doing when you were all right, let's write a new open source tool that goes and does what KRR does? What was the motivation? How did you decide this is my next thing that I'm going to build?
So it came up because we heard again and again from people who were using Robusta and were using the other stuff, our other platforms. And they came to us again and again. They said, okay, how can I set CPU requests? And how can I set memory requests? And what should they be? And the reason it came up is because we have alerts in Robusta about reliability issues. We didn't do anything related to efficiency, but we had these reliability alerts, like you're having CPU throttling because your request is wrong, or because you set a limit that's blocking that. So we started getting reliability questions, and very often the answer to that reliability question was you need to set your allocations differently. You need to allocate more CPU up front for this, or you need to allocate more memory up front for this in order to make sure it runs smoothly. And we tell people that, and then they come back and say, okay, well, what should I put in for the CPU request? What should I put in for the memory request? And our answer was always like, okay, well, look at the vertical pod autoscaler, look at these other systems. And we kept on hearing from people, no, that's not working for me because of X, Y, and Z. That's not working for me because I can't actually use the VPA because I'm using the HPA at the same time. Or I want to use the VPA, but how do I know when there's a new recommendation that I should apply that's off by 20%? Or I want to use the VPA, but I want to get recommendations that are stable over time that aren't constantly changing. So we started hearing a lot of this, and the first thought we had in our mind was, okay, we're going to take the VPA. For people who don't know, the VPA, or the vertical pod autoscaler, was until KRR, I think just probably the only real way at scale to determine this stuff in your cluster, determine request and limits. I'm probably forgetting something. I shouldn't say that. I'm probably forgetting other tools out there. But it was the number one way.
Yeah. I mean, there are other tools out there that don't actually integrate natively with Kubernetes, like Parka, which can profile our application and tell you what values are over time, but you still have to do the analysis. You still have to kind of look at that and work it out and configure your own VPA and stuff like that. So definitely there's a lot of room for tooling to improve and make this easier for teams.
And there are proprietary solutions out there as well, I should say. There are proprietary solutions, I think, specifically for Kubernetes that also can do it. But there was no, other than the VPA, I think, there was no open source way that we like to do it. And then the first thought that went through our head, and I said to the team, we're not developing this from scratch. I was pretty stubborn for a very long time with the team. And the team said, we need to develop an alternative to the VPA. And I said, we're not developing an alternative to the VPA. Take the output of the VPA and add on reporting features, give a better experience, but we are not developing an alternative to the VPA. It doesn't make sense. And eventually I caved because we looked at it, and we really looked at it from the product requirements and from the product spec and what we wanted to accomplish with this. And we discovered we couldn't do it on top of the VPA. So I was kind of dragged kicking and screaming and objecting the entire way into, okay, you know what, we will do our own recommendations engine.
Okay. So I'm not that familiar with KRR. Is it a replacement for the VPA?
We do.
I mean, sorry.
No, go on.
Yeah, sorry. I seen the announcement. I went on the GitHub page. I kind of gave it a scan. You know how I like to do these streams. I like to come in with fresh eyes and really learn from you, right? Rather than trying to make my own assumptions up front. But from what I've seen is a command I run locally, and there's nothing in the cluster. So I didn't come into this expecting it to replace the VPA. I thought it'd be something that gave me a VPA starting point or something. I wasn't actually that sure. So maybe you can correct some of my assumptions then.
So the VPA has two modes. One mode is it runs in cluster and it's constantly monitoring your pods, and it's very heavily weighing its recommendations towards the last 24 hours. You can tune that, of course, but that's the default. And then it's constantly updating your pods. And that we're not doing. We decided, at least in phase one, we are not modifying anything in production. We are read only. We will give you a recommendation, but it's up to you to apply that recommendation to review it. And this is a human in the loop process. So we're not competing with the VPA that runs in cluster. But we actually did some studies. I did some surveys on LinkedIn, and we had a lot of user interviews. And we discovered that most people aren't running the VPA in the automatic mode. Most people are running the VPA in recommendation mode, where the VPA gives recommendations and then the human looks at it, and then you go and you apply that. So for that mode, we are competing with it. We just don't make you run something constantly in your cluster.
Got it. Okay, nice.
So that comes back to also why we had to build this ourselves, even though I was very, very much against it at the beginning. To use the VPA, you have to install something in cluster, and you start getting recommendations in the future. Whereas most people already have a cluster like I have a cluster here set up locally now. It's had Prometheus forever. And when I show KRR in a few minutes, I'm just going to run KRR on this historical data, and I'm going to get the recommendations immediately. And that ties back to what we want to do with Robusta, which is you have all this observability data. I want to unlock like the gold that's already hidden there. So we wanted to make it as easy as possible. We wanted to give you a command you run locally. We didn't want to like add on any friction for running something in your cluster because maybe you don't have permissions to do so.
Okay. Well, I guess we can dive straight into the demo, or I can guess what we're going to see. It's entirely up to you. But basically, you've mentioned Prometheus, you've mentioned KRR as a CLI tool. I'm assuming it's a nice way of running queries against workloads on Prometheus to get top, middle, bottom values across in a certain amount of time, and then make recommendations based on top of that.
Yep, that's right. So let me just, I'm gonna clear my screen and I'm gonna share my screen. Let's see.
Yeah, go for it.
And let me blow this up. Can you see my terminal window?
I am just going to make that happen. All right, now we see your terminal. But can you make the font a little bit bigger, please?
Yes, I will.
There we go. Perfect.
And can you see, I want to get over here. Let's see if it follows. So this is just the GitHub. So first thing I want to do, just to give you a teaser, this is what we're going to get. What we're going to get in just a minute is we're going to get these recommendations. So for everything that's running in my cluster, I'm going to find out what should be the CPU request, the CPU limits, the memory request, and their memory limits. And this is based on that historical Prometheus data. So let's go back though. So the first thing I'm going to do is I'm just going to install this. And I can install this a few different ways. I can either install via brew, or I can install by just cloning the code. So I'm going to just clone the code. And there we go. And I'm going to go back now, and I'm going to install the requirements. And this is with Python. Of course, you don't have to have Python. You could just use the pre-built binary, so you don't actually have to have Python to run this. Whoops, clear. And I'm going to go back. Finally, I'm just going to copy this command. And I believe in my case, it has to be Python 3.9. And I'm not going to get anything by default. It's going to ask me to choose a strategy. And right now, we have one strategy that we call simple. And this is the strategy for how we calculate what the CPU and the memory should be. So the default strategy, the first strategy that we implemented, it will find the maximum amount of memory. And it's going to use that as the baseline for how much memory your pod should get, the maximum amount that they've used in the past. And for CPU, it's going to go, and I believe I will have to zoom out to get something formatted nicely.
Yep.
So let's just run that again. And for CPU, it's going to go and it's going to take the 99th percentile. So what we're trying to do here is we're trying to understand, based on historical data, how much CPU and memory your pods need. And then by setting that number right, then we're going to be able to reduce costs while still maintaining reliability. And that is really all there is to it. So I just ran that, and it's connected to Prometheus in my cluster, found it automatically. So I didn't need to point at Prometheus. I didn't need to do anything. And it went and it looked at each of the workloads running in the cluster, and then it queried them in Prometheus, and it found here the historical data, and it's telling me what I should set based on that historical data.
Nice.
So if I take an example here, then here's an example, the Argo CD application set controller. And right now that has no CPU request. So it's telling me, one, I should set a CPU request, and two, based on historical data, the right amount for this would be 5 milli-CPU. The memory request is unset, but based on the historical data, what this needs is 23 megabytes of memory. And then for limits, for CPU and memory limits, and there are different approaches to how you set that. And there is some controversy around that, around different opinions. But we have some options also that we're going to expose for how you can control that.
Nice. So it scans my cluster, gives me recommendations. I can pump them straight into my GitOps pipeline, and off I go. I've got a happier cluster, right?
Yep.
Yeah. I think what's interesting here is like, I work with, I guess I'm in a unique position, right, as a consultant these days, where I don't work in my own cluster. I spend a lot of my time working with everyone else's clusters, which is a blessing and a curse. But what I've seen constantly is that people really overestimate their CPU requests on all of their workloads. Like, usually they're straight in there with the 500 millicores, half a core, and you're like why? Like that's a lot of CPU to be thrown into your 3 meg Go application that runs once every 15 seconds or whatever. And I think just having tools like this that can give people visibility into actually what the average application really needs from a CPU request kind of view is much less. Like, I don't think I've ever seen someone with a cluster that applies 5M as their CPU. And I think that's very eye-opening. I hope it's eye-opening for people that you don't need to go nuts with this. And even when it's not 500, they set it to 200 or they set it to like 150. It's always very high numbers. And I'll call out GKE here for being notoriously bad. But if you run, sorry, GKE, but if you run an autopilot cluster, it actually does like automatic VPA for you. And again, it over provisions by a factor of 10 based on what I've seen as well. Like it's hugely over provisioning.
Yeah, we've gotten some feedback from people that we should over provision a little bit more to give a little more buffer. So we're actually considering changing it from like 5M to 50M. But if you look at the big scale of it, it's not even the 50M versus the 5M, right? Because how many applications do you really have with 5M or 50M? It's with those 500 megabyte or those one core machines. Yep. And if you go back to that Sysdig study, 69% is over provisioned on CPU. So take a typical company that has a cloud bill of, let's say, let's say 5K a month on GKE, right? Or on AWS or on Kubernetes. So if you're paying 5K a month and let me just do the math now, and you're 69% over provisioned, then you're paying almost 3.5K extra a month. So more than half of, like, that's slicing more your cloud bill in more than half.
Yep. Yeah. I don't know. I don't think I would go from 5M to 50M, even if people are calling on you to make it higher. Like, I would encourage people, run KRR, but then back it up. Run kube-control top pods and see the low numbers for the current utilization of CPU. Like, it's never that high. Unless you've got a Java workload in there in which you've got other problems, I'm really sorry. But, you don't need high levels of CPU requests for most workloads.
So this is what I'm actually the most excited about in terms of what we're working on. You get a recommendation like this. The first thing that you're going to go and do afterwards is you want to validate this recommendation, right? And you're going to go and you're going to look at a historical graph of this data. And then based on that historical graph, you're going to like draw a line across that and say, okay, how would I have performed on this recommendation in the past three weeks, right? So we're actually, what's like being worked on right now that I really wanted to show on the show today, but it wasn't out in time. But just any day now, we're going to have this out, is to be able to also show you the justification for these recommendations, to like show you it on a graph, and then to draw a dotted line across, say like, okay, here's what we're recommending. And then this is how that would perform in historical data. And so that's one of the things that we're working on right now that I'm really excited about. Because like you said, you're not going to just go and apply this recommendation probably. You want to see why, right? You want to visualize it. You want to go through and do this whole process. And then when we think about like how we give you recommendations, it's not just about giving you the recommendation and the number. It's about giving you the confidence to apply it.
Yeah, definitely. And like, if we go back to what you said at the start of this demo, right? Like, you're doing Prometheus request. You're looking, how long did you say this data is over? Like what, 3 months or longer? Is it all time?
So it depends on your Prometheus.
Right? Yeah. So if you've got a retention policy of say 3 weeks, or maybe it's 30 days, it doesn't really matter. I mean, this is the max value over that retention policy. So I think that's really cool for people just to really get that front and center. Like, you maybe don't need to draw a graph in the terminal, to even just pop them a link and say, go look at this in Prometheus yourself. Like, go and take a look and see. And they might even, maybe in some cases, we do see a couple of large numbers there. You've got your platform relay using 261 millicores, right? that could have been a spike for 30-second window 2 weeks ago. Like, you really don't
You
know.
want to see it. Yeah,
Yeah.
you want to see it. But so I'll tell you something that's very interesting. When you look at what's the maximum, it actually depends a lot on what time period you're looking at. So imagine that you say, I'm going to just go into Grafana and I'm going to look at a 2-week period. And then in that 2-week period that I'm looking at in Grafana, I'm going to take the maximum, right, of CPU. But it actually, what that maximum is actually depends on what your interval is that you're sampling at. Because imagine you have a pod that runs and it's doing nothing all the time. And then it spikes for just 1 second and it goes all the way up to 10 CPU and then it goes back down. And now you take it and you graph this data over a 2-week period. And when you're graphing over a 2-week period, you're like taking 1 hour intervals and the average over each hour. So you're never going to see that spike on that graph. It's just going to be a flat zero the entire time.
Yeah. And I think that's still okay, right? I mean, these CPU requests are a scheduling concern. They're not a runtime concern. It's not like your application can't consume above these requests. So they're there to help a scheduler so you don't over-provision nodes and you reduce a class of problems that probably don't really need to exist, well considering the cost factor of just infinitely scaling the number of nodes that you have. We have a question from Russell in the chat, so I'm going to pop that up. But Russell asked, does this tool, or could this tool, I guess, have a report that shows the idle time of each node? So, really trying to hammer home that point about that 69% non-utilization. Like, can you show that on a node basis or pod basis for these workloads? I think that's a good question.
Yeah, so not yet, but it's also coming. So when you think, and it also matters, so it's both on the node level and the pod level. Like on the node level, you want to understand like what's the utilization, what's the idle time, right? Like how well am I doing, or is my company or team doing as a whole when it comes to efficiency? Like, am I doing 9 out of 10 and then I'm not going to worry about improving this as much? Or am I doing like 1 out of 10 and then I should really go and focus on this? So we don't yet show the nodes, but it's something that's being planned. And then to tie into what you said about the pods, it's not just the number here. Like if this number matters, it actually is the difference here times the number of pods. Because think about it, like if you have an application, a replica set that has 100 replicas, and you have 100 megabyte difference on all of them, then it's actually 100 times like 100 megabytes. So it comes out to be bigger.
Yeah. Those numbers could get crazy pretty quickly, actually. So you mentioned that this is the simple strategy and that more strategies are going to come. I'm assuming you're looking into things like linear prediction, whole winters, other statistical proxies for understanding growth over time, averages over time, etc. Maybe you could talk about what's coming or what ideas you've got for other strategies.
Yeah, okay. So imagine, I'll give you in a scenario.
And don't say OpenAI ChatGPT. I don't want to hear it.
I'm not going to say it. I'm not going to say it. And I just see Russell said here in the chat that you want to see over time, so you can see the nodes on something like 30% average, and then on times it can go up to 70%. So yeah, absolutely. I don't know if that's something we're going to expose in the CLI or if it's something we're going to show in the SaaS platform. Maybe I can just share my screen for a second. And I still want to answer your question about the strategies.
Yeah, of course.
Let me see. Okay, so I'm going to answer the question about the strategies first, and then maybe I'll show something else afterwards. So imagine you have a workload now where you're running this workload and like every weekend it does nothing, right? And then the entire week it goes and it's like burning CPU, or it has some cyclicness, right? So what you want to do is you want to apply an algorithm, let's say like hold winters, right? And you want to understand you want to understand that there's some cyclic behavior here, and like there's some periodicity, and that on certain days it performs a different way. But you can't go and just set a request and a limit, because when you're setting a request and a limit, you're setting a flat value. So in order to do this properly, then what you have to do is you have to have two parts that go hand in hand together. on the one hand, you have a better algorithm that understands the historical data. But on the other hand, your output, it has to be richer output than just getting the request and limit. And then there are two approaches you can go with this. Like the first approach is, okay, we're going to write this really complicated Kubernetes operator, and we're going to apply all these different stuff dynamically in cluster. And we're going to do it time-based, or we're going to do it based on like what's coming into Kafka now. We're going to do it based on the CPU load. But actually, all that already exists. Like if I want to do it scale based on time, then Kada has this really cool thing called like a time scaler. And I can say with Kada, this pod should run however many replicas on this day of the week. On this day of the week, it shouldn't run at all. On this day of the week, it should run 5 times as many replicas. Yeah. So what we want to do with other strategies is to have strategies that have better algorithms. And in terms of the output, though, we're not giving you just a request and limit. We're giving you an HBA config. We're giving you a Kada config. We're giving you we're generating the Kada or the HBA config for you based on that historical data.
Yeah, I think that would be really powerful. Go back to the example that you were talking about. Let's assume you're an e-commerce store that your traffic sits at 5M for 11 months of the year, or 10 months of the year, right? But then at Black Friday and over Christmas, you've got these incredible spike in traffic and sales, and you don't want to lose anything, right? You don't want to lose money just because your infrastructure can't cope. This is where Hope Winters and similar algorithms really excel, because they can detect that cycle within the data and what the affecting other factors are if you have that kind of data. So I think it'd be really cool to have that kind of thing in KRR. And again, this comes down to people having retention periods and doing downsampling of their metrics, which I think is a whole other world of stuff that people need to get better at. I think Prometheus has just taught people to have a 30-day retention window, only look back 30 days, but actually you need to be downsampling that data and storing it for long-term analysis over 12, 24, 36 months. And really, if you want to get good at this stuff, that is, of course. But having KRR be able to understand that, work with that data, and create a Kada profile would be really, really cool, especially for these use cases where there are a lot of e-commerce companies where they have to scale up at Black Friday and at Christmas. There are seasonal companies like holiday travel agents that get really busy when people want to book their summer holidays. There are Scottish people who just drink a lot of whiskey at New Year, and of course that's going to spike traffic somewhere on the internet, maybe Twitter, who knows? But this opens that all up. So that's a really cool enhancement. I'd love to see that come to KRR. And especially hooking into Kada, because Kada is a really cool project in this space as well. So
I can say that as someone who used to be a developer and someone who occasionally has to set the values in these YAMLs, there's a black art to how you determine the right Kada config or how you determine the right HBA scaler. And what we want to do is we want to make it all really simple. So if I take it back to where we started this conversation, and people are moving to the cloud, and you're moving to Kubernetes, and the cloud is supposed to bring you all these awesome cost savings. And then you look at it, and you have these nodes that are at 30% utilization, right? Mm-hmm. It didn't deliver on that promise. And a big part of what we're trying to do is, with open source software and with your existing observability data, to say, okay, yeah, there's some added complexity here with Kubernetes and of course, with the cloud and with Kada and with HPA, all these things add complexity, but we can get you to this maximum that is way, way better than where you were when you were running on-prem or you had your own data center. But you have to be able to take that data and to be able to extract meaningful insights from that.
So there's something kicking around in my head, and I know you've said, right, that you were dragged kicking and screaming into not working with the VPA. And you've also told us on this stream that, it's read-only. You don't want to modify a cluster. But I'm sitting here and I'm looking I have a Robusta in my cluster already, right? There's an operator that does things. Would you not look at just kind of broadening the scope a little bit and trying to hook into creating these horizontal pod things, updating objects in Kubernetes cluster? Is that not something? I mean, you're right there, right? It's open that door. Are you going to open that door? Or are you going to just keep it shut? I'm not sure.
Okay, so the big question here is GitOps. But we'll put GitOps aside for a second, okay? We're open to generating these HPA, to generating an HPA or to generating a Kada config we're open to creating like what you need in order to scale. What we don't want to do is we don't want to be the one who's like constantly watching that pod and then scaling it. We want to reuse what's already there in KDR HBA.
Okay, cool. I think that was closer to a yes than a no, but I'll leave that up to interpretation of anyone watching. So, did you? Sorry, on you go.
No, is there some lag here, or is it just on my end? I'm curious.
No, I've noticed a little bit of lag too. I don't know if it's just the internet. I don't know if it's the streaming software. I don't know if it's the weather. Who knows? But so far, I don't think we've dropped anything, so I think we're okay. You said you were possibly going to show something else. Would you like to do that now?
So we're also sending this data to the Robusta SaaS platform, and I just want to show a few other ways that you can use this actually. So I want to start with Slack reports.
Are you sharing your screen, sorry?
Yeah, I'm about to start sharing it.
Okay.
So I wonder if the lag might be on my end because my browser is freezing up. But okay, let me see. One moment, I'm just going to pull this up.
Yeah, of course.
Okay, so I want to start with another use case that's come up that we've heard from a lot of people, which is, okay, I ran KRR and I got a report once, but what happens if 2 weeks from now some new application is deployed to the cluster, or something goes way off 2 weeks from now and something changes in one of my applications? So what we've actually done is we've done an integration with our other open source software for Robusta that's, like you said, already running in cluster. So we can then do a scan on a specific schedule that you set, like let's say once a week. And then we generate a PDF report for that, and we just send it over to you in Slack. Can you hear me, David?
Yeah, I think you maybe dropped off for a second there now, but you're back. Okay. So you generate a PDF report and you send it over.
Let me refresh my screen for 1 second. I might drop out of the call, but I think that'll fix the issue. Sure. Is that okay?
Of course. Go for it.
Okay.
Welcome back.
Yeah, okay. Am I back in the live stream?
You are indeed.
Okay, so let's try that again. So yeah, what I was saying is one thing that we want you to do is we want to help you put this on autopilot and then kind of forget about it until there's something else that requires your attention. So one thing that you can do that I don't think we're highlighting enough in the main repo yet is you can configure a scan that runs periodically, like once a week. And when that happens, then you just get a report here in Slack, and you can go over that and then see any new recommendations.
Oh, nice. Okay. So Robusta in cluster does the KRR scan for you, and then you can get a nice little report whenever you want, showing you how good or how bad your current setup is, right?
So. Exactly. So we're sending that to 2 different places. The first is to Slack for people who are just using the open source side. So we want to make sure they have a way to get the periodic weekly recommendations. And then the other thing we're doing is for people who are using the UI, which is part of our SaaS offering, then we're also sending stuff over here. And here you can see the same recommendations in the SaaS platform.
Oh, cool. Nice. A nice value add to the SaaS platform now then.
Yep. I think though, like for the Sophically, then we want to make sure that we're always balancing the 2 things. Like on the one hand, adding functionality to the SaaS, but on the other hand, making sure that people also have a workaround and they can still get this in a pure open source way if they want.
Yeah, and I think it gives people the ability to kind of onboard themselves to this flow at their own pace. Like if you just want to run KRR once a month from a developer's laptop, sure, right? But once you get a bit more, I don't know, confidence and you want to start pushing that more through more automation, you get the report. And then, I'm sure we'll be chatting in 6 months' time when Robusta is just hooking into Kata and doing other cool stuff too. So looking forward to seeing that in the future.
I wish we were there already, but it's going to take some time. But it's one of the things that most excites me, being able to like even just speak to people at a conference and just having a casual conversation. Someone says to me like, okay, well, how should I scale this microservice that's new here? And just say like, run one command, you're done. It'll check like 5 different strategies. It'll tell you what's most optimal. It'll give you the menu. You can look it over and choose, or you can take the first one if you don't want to think about it. I want to be able to say to people, like, you're now speaking as someone who's like an advocate for Kubernetes, I want to be able to say to people, like, scaling is a no-brainer. Like, you don't even need to think about it. Like, you want to configure auto scaling, just run one command, don't think about it. You want to configure Kata, just run one command, don't think about it.
Nice. Awesome. So I'll finish on one last question. Right now, we didn't actually dive into we did, right? It's looking into the metrics of I guess this is from metric server, from the kubelet, where it's looking at the CPU utilization and the memory utilization. Is there a future where it tries to go beyond those metrics and actually take a look at the HTTP latency to understand, well, actually, you're only using this much CPU, but if maybe that's because there's other things in place, maybe there's CPU limits or whatever, or contention, but your latency is quite high. And it's like, well, okay, well, you could probably bring this latency down by allocating more CPU, or maybe even it's running on a different type of hardware. Like maybe there's cloud awareness that comes into KRR that says you're running on like a XS tiny box on Amazon with like a 1 megabit network card. Maybe you need to start looking at bigger ones. Maybe you need gigabit Ethernets. Maybe you need multiple Ethernets because you've got a lot of contention on a single box. Maybe you need to switch to ARM processors. I don't know. Like there's a whole wealth of stuff out there. Like scheduling isn't just taking the hardware that we have. It's capacity planning and looking at how do we improve that. And I wonder, maybe it's not in scope now, but maybe it's something in the future that could be a value proposition for KRR and Robusta too.
So you're the second person in 2 days to say that to me about HTTP latency. So I think there is something to it. It's not, I think in the first drop, we're going to be looking at, like, if I think of how we're building this, then, okay, we have base recommendations today. The next thing to do is to give better explainability about why we're giving the recommendations we have. And that's like really going to land any day now. So you can see that graph, you can understand why we're recommending what we're recommending and play with the thresholds if you want to. And then the next thing, like the next level, is to be able to say, okay, I'm not just going to recommend as output taking like a fixed request or a fixed limit. I'm going to be able to recommend HBA config. I'm going to be able to recommend the Kata config and so on. And then for me, the level going like one beyond that is then to be able to say, okay, I'm going to look at when I optimize this, when I analyze it, I'm not just going to look at CPU and memory. I'm going to be able to look at this bigger holistic picture. And then that's one side of it. And then the other thing that you touched on is there's this fundamental relationship between your nodes and your cluster autoscaler and between your pods. And the good example of that is like, let's say we give you a recommendation that you should set, like 1 CPU and 1 gigabyte, but all your nodes have 10 CPUs and 20 gigabytes. Then based on the ratios, you will always have wasted memory on your nodes. So there's a relationship here between scaling your pods and like setting up requests and limits for your pods, and between handling the actual nodes in the cluster autoscaler side. So that is something we're looking into as well.
So yeah, identifying those parts of memory that can't be allocated because the CPU is utilized, right? Or not even utilized, just that it's been allocated by the scheduler. So it's never going to, that RAM's sitting there unless you can get a workload on it that actually takes it over. Yeah, that's a nice idea. I like that a lot.
But you have to freeze stuff. It's like you're looking at this like 10-dimensional problem, and you can't run on all the dimensions at once. You have to like freeze like 9 dimensions and say, okay, right now we're just optimizing for CPU and memory. And then as time goes on, as you build something that's more and more complex, then you start adding more more degrees of control and like unfreezing some of those dimensions.
Yeah, well, we have a question about one of those other dimensions, which is important for our stateful workloads in Kubernetes in the chat, where Russell is asking about tooling that surfaces the availability of IOPS within container workloads on nodes. I guess that could be another dimension that KRR could hook into.
Yeah. I hit a nasty issue with this once, where I had a Kubernetes node that was going missing in action. It just would suddenly freeze up on AWS. And when you looked at it, it was because it was like an AWS node with like a burstable number of IOPS, and you used up the burst quota on the IOPS, and the whole node froze up. So you could get that in a Grafana dashboard. I think the team is adding that to Robusta as well in the dashboards we have. Can you get it? You can't get it in kubectl top, right? I don't think it shows you IOPS.
No, it doesn't. You would have to. Yeah, it would. It's not surfacing of the metric server or the kubelet. I don't think. Yeah, you're not going to have access to them.
And you can get it probably with the eBPF based stuff too, right? Like with.
Yeah, I mean, I think from the kubelet metrics, you might get like the flush time and FS intervals. I don't know if you're specifically going to get the reads and writes. It's been a while since I've dug into that, to be honest. So I'm not entirely sure. There may be stuff there, but it may be that you have to instrument that another way or use a node exporter from Prometheus to grab extra metrics there.
Yep.
All right. Awesome. Well, thank you so much for your time today. Is there anything else you want to cover before we finish up?
Just a request from everyone. Like, this is new. It's still in beta from our perspective. So we're testing this out. We're getting feedback from people. And we're taking all that feedback to try and make this better. Like just this in the past day or so, I got feedback from someone who's using this with HPA, and about an edge case there where like the HPA was trying to drive stuff in one direction and was trying to reach 50% utilization, but the recommendations we were giving were trying to reach like the P99, right? So we're trying to really make this like the best tool out there for determining requests and limits on Kubernetes for maximizing utilization, and to do that in an open source way. But to make it happen, we need help from everyone out there. We need feedback. Like the biggest challenge when you build an open source project is that people take your project and they use it and they either love it or they hate it and say, I'm never going to use this again. And they just never speak to you. Whereas if you think of like a company that's sales driven, then that never happens because you're like, people have to jump on calls with you and you see the feedback. And if you gave them bad advice, you hear about it, and if you give them good advice, you see they're happy. So I just want to request from everyone out there who's listening to this, please give us your feedback and open up GitHub issues, jump on the Slack channels, speak to us, message me on Twitter or LinkedIn. We want to hear from you how we can make this work for you. And I'd say the number one thing that I've learned also as a founder is when you, like, I can't count the number of times that I've had someone say to me, I guess there is some feedback I could give, but I think it's only specific to my company, or it's just about how we work. And then you double click on that and you discover it's something that applies to like 9 out of 10 people. So even if it's specific to your company, speak up and tell us, because very often it's not just you.
Awesome. All right, everyone, if you're listening, go check out the repository on GitHub, open up issues with ideas, bugs, and make sure you give them as much feedback as you possibly can. We did get a last question sneak in there right at the end.
Yes, I have to address it. I have to. It's an excellent question. And so let me give background on what Goldilocks is for people who don't know. So Goldilocks is a platform on top of the VPA that exposes the VPA recommendations in the web UI. And they also prevent you from having to configure VPA for each and every workload. So they're doing two things. They're giving you the VPA recommendations in the web UI, and they're configuring the VPA for you so that you don't have to configure it for each and every deployment in your cluster. So I guess the difference between KRR and Goldilocks is the difference between KRR and the VPA. And just to go over that again briefly, so we don't require installing anything in your cluster. You just run a command line. We take the historical data and we can give you recommendations immediately. And in terms of what we're like trying to accomplish, the biggest thing that we're trying to accomplish is to, one, give explainability. So not just to give you a recommendation, but also to show you the data that supports that recommendation and give you the confidence to apply that. And that's something that we're going to like just any moment release something for. And then the other thing that we're trying to do is to give more complex recommendations and like analyze this historical data, not just output a single request or a single limit, but to be able to output something that's richer than that, like HPA, like a K to config and so on. And then, of course, in terms of reporting features, then we're very like focused not just on the recommendations, but how you consume them as well, like getting a weekly Slack report, getting a table, like showing what's the biggest priority thing to look at, and so on.
Nice. Awesome. Hope that answers your question, Jason.
But Goldilocks is good. Like Goldilocks, and if you're using the VPA, you should use Goldilocks too. It's
not a project I'm familiar with, but something I'll look into after the stream and take a look. All right. Thank you again for your time. It's always fun to see what new ideas you come up with at Robusta. Thank you for coming onto this channel and sharing them with people. I hope people do get involved, open issues, and give you feedback. And hopefully we'll see each other again soon. So thank you, Nathan. Have a wonderful day. And to everyone that watched, we'll see you next time.